All right. Advent of Code day 7. Get my things set up here. Okay. Once again, using the Kotlin programming language. Really fun language. I like it. It's just, generally I think, hey, can I do X? And yeah, I can do X. So, bridge repair. Okay, here is test input. Oops, not what I meant to do. Okay, so I have what looks like a really big number, at least the long, followed by a bunch of smaller numbers. Although my guess is this may be more string manipulation, I guess. Okay, I see. So, okay, historian, take you to the familiar rope bridge over in the middle of the jungle. The chief isn't on this side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks frequently. You ask how long it'll take. Uh, Stole all the operators. Okay, so I need to plug in operators. They could finish, blah, blah, blah. Operators are always valued left to right, not according to order of precedence. Furthermore, the numbers in the equations cannot be rearranged. You can see elephants holding two different. Okay, so plus or minus, or plus or times. Okay, this is straightforward, and it is the sum of the test values from just the equations that could possibly be true. Okay, so for each line, hang on, but can I concatenate numbers? No. Okay. For each line, it's going to be lines dot split, or sorry, it's going to be val answers equal lines dot map, and it's going to be it dot substring before colon dot trim, and it's not going to be too int, it's going to be too long. And something that I'm going to do here is make sure, okay, so this is input.text. Let me just make sure there's no like blank lines or anything at the end. Good. Okay. And then it's going to be val, going to be operands equals lines.map, substring after colon dot trim dot split on space. I know how to do this. Okay, so dot split on space, dot map, and I'm just going to make this too long just to sort of make my life a bit easier. Okay, and then we're just going to do print line, and we do answers dot, well, let's just do print line answers, and then print line operand. Make sure we're parsing the input right. So this is just going to be like, this is certainly small enough to brute force search. I mean, even on the longest of these, it's just going to be 2 to the n, or 2 to the n minus 1. And none of these are long enough where I worry about them. So I can exponential this. And there's some shortcuts I can take. For instance, if I end up with a number that's too big, right out of the gate, what I know I can do is I can just I can short circuit it and say, okay, stop searching this way. Um, and then there might be a better option where I do like kind of a sorting thing that lets me break up some stuff. But all right, map it dot too long. Yes, okay. So now I'm then going to do get part one result, answers, operands. I'm going to add these in. And it's answers.zip operands. I'm going to zip these together, and then it's going to just be something like dot count. It is possible. It dot first, it dot second. And then I'm just going to return that. And from there, this is going to be a. I'm going to add a argue or a int equals 0. So let's do it this way. I know how I want to do this now. I'm going to do require longs dot is not empty, and then I'm going to do a helper function. So this is going to be answer, and this is going to be shift F6 operands. And it's if possible, then it's going to be answer long operand long operands. And then it's going to be current, which is a long, and then it's going to be index, which is an int. And so this is going to be my recursive search, and I'm going to just do turn is possible, answer operands, current is 0, or no, operands dot, I know what I need to do, operands 0 or dot first, and then it's going to be 1. Okay. So I can do like a quick little short circuit here. If current is greater than answer, if current is greater than answer dot too long, then return false. If current equals answer, then turn true. And the other thing we're going to check is if index is greater than or equal to operands.size, then return false. So these are my base cases. If I have found the answer, oh it's actually more complicated. If and index equals operand size 1. Right. If it'd be something like what? Like, is there a last index? There is. If the index is no, it'd have to actually be operands.size. For where I'm going with this, I want it to be operands.size. Because the point is, I'm going to step through, and then it needs to be right basically when I get past the end of the list. So we're going to do that, and then it is just a matter of, if we reach this point, we get to the recursive step, which is return, and it's going to be val plus, okay, and it's going to be current. Let's do it this way, just to kind of keep it more sort of readable. And it's going to be no, that was right. Current plus operands index. I don't like the dot plus there. I think that's weird. Sum, and then it's going to be val product equals current times operands index. I bet part 2 is going to be we have a concatenation operation. That's what I'm guessing right now. But we shall see. Sum product and then it's going to be return is possible plus 1 and is possible product. Right now, answer operands product. Okay, so there we go. And not and, excuse me, or. Again, let me just make sure there's no like negative numbers here. There's no zeros either. Let's do Control F base 0. Just because I'm making an assumption here that it's always increasing, and if you could multiply by 0, it would sort of change things. But I think this is right. Okay, let's try this on our test data. Ooh, out of bounds at here. What? How am I getting it out of bounds? Index -1. Oh, because the autocomplete fucked me. That's why. Oh, but I need to get the sum of that. So it's actually going to be filter is possible dot sum. Oh, wait, it's dot map. Oh, sum of it dot first. And let's just change that to long. And I got the right answer. Okay, so, yep, good old fashioned recursion. And a big number. Really, really big number. I'm gonna get rid of my printing here and retry that. 2. Yep, big number. That's the right answer. Okay, yep, concatenation. Combines the digits. Operation still valued as the right. Okay, yep, so this is um let's just try to get to part 2 first. So and then I'll clean it up to sort of make it look nice. It's just gonna be uh or and it's gonna be cat equals current dot toString plus operands index dot toString dot to long. This is the number I got. Let's just see if it's right. Going for a fast part 2. But yeah, fast part 2. Okay, how did I do? Did I get under? I'd be so ecstatic if I got sub 1,000. I did not get sub 1,000. Damn, not even close. Not close. But you know what? That was still good. In fairness, this was pretty easy. Um, my part 1 was slow. I think I was just slow typing. It's not that hard a problem. I think I was just slow typing and sort of slow thinking through the recursion here. Okay, let's explain the code first. Um, and then I'm gonna fix it to where it's just working for, uh part 1 and part 2. I'm just gonna break these up in some way. I mean, the easiest way is just is possible shift F6 is possible P2 and then okay, is possible P2 and then it's going to be um it's going to be the same stuff for P1. Like let's just 1 and P1. Yes, there is duplicate code, but then there's one key difference. No concat here. Oh, right. Okay. Oops. And I need to make that P2. Possible P1. All right. So I have an idea for sort of how to handle um, things, but the the key idea with this recursion is, well, how do you do recursion? Base case, recursive step. Uh, the most obvious base case is that we find the answer and our index is reaching. If we find the answer early, that's wrong because we have to use all of the numbers. We can't just disregard the next number in the sequence if we're too early. So index equals operand size. The point here is if we reach this point, we're either returning true or false. So it's true if the current is equal to the value of answer. And this is why, we have, um, we start with the first operand as the current value at index 1 being the next thing to get. Um, these are just like sort of passing in the input data, but the point is we start our first step of our recursion by saying, okay, the thing at index 0 of operands, that's the value we're starting with. And we're going to look at the next thing, index 1, the thing after index 0, right? So then if our current is equal to our answer, then yeah, we won. Yay. Well, and we're at the end of the thing. If current equals answer early, that's bad. That's no bueno. If current is greater than the answer, then we can terminate early. Using this will help us out. Just it'll prevent us from sort of recursing down steps that we don't want to do. In fact, it might actually be faster now that I think of it if I swap the order here. If I do product before I do sum, that might help me out a bit. Let's see. I, I was I was very wrong. Um, that doesn't even make a huge difference, actually. Okay, yeah, it doesn't even make a huge difference. Anyway, point being, though, if our current is greater than our answer, since the number can only increase because we're only using addition and multiplication, I could not do this if we were doing, say, division and subtraction. If those operations were available, then no, we couldn't do it. That's why, like, my instinct, because I even said while I was working on part 1, I bet part 2 is going to be concatenation. Part of it was just how big these numbers were, and part of it was just saying, like, the second that you add in subtraction division, like, you just can't use this short circuit anymore. You just can't. And also division would be weird, because what if it's not an integer number? And I could just see problems emerging from that. Okay, anyway, last is that if our index is past the end, we've used the operands, but this condition was not true, then that means we have not found a value returned false. But the key is this is our base case. Our recursive step then forks. So we get the sum by adding current plus operands. We get the product by doing current times operands, the next operand. And then we recurse on the multiplication and on the plus. We just recurse on that. The key is, in addition to updating the number, we have to say index plus 1. We have to recurse towards our base case and say use the next number next time. And then from there, part 2 is easy because part 2 is just add concat, which is take the two strings and plop them together and convert it back to a, take the two longs, convert them to strings, plop them together, turn them back into longs. And it's literally just, okay, we just add a third leg to our recursive step. Doesn't change the base cases at all. From there, though, again, I want to see if reversing the order of these maybe makes a bit of a. I mean, it would not make a huge difference because I'm not changing the big O notation here, but my guess is concat is typically going to produce sort of the largest effect. And so I figure if I do these things in this order, I might get a small performance gain, or I might even be slower. Well, it's super inconsistent. Okay, it seems like this is better. Okay, it seems like this is better. Okay. So just slightly. I mean, I'm still taking, this is in microseconds, so I'm still taking almost half a second here. Um, it is an exponential solution, an exponential runtime solution, but hey, At the end of the day, like I'm happy with this one, right? Like again, 2537. I think if I weren't talking aloud, I could have improved on this pretty considerably. But then, it took me what, a minute and 14 seconds to do part two because I just had to add one line of two lines, calculate the concat, and then add the concat branch. And that's it. So I like this. This is a really good, simple little recursive path finding problem. I mean, that's effectively what I'm doing is I'm finding a path. I like this problem. Fun problem. Yay. All right, let's do our commit. This is day 7. Commit and push. And there we go. All right. Oh, let's check my little private leaderboard. So I'm gonna see first the Kotlin one. You know, I'm doing pretty well here. Right. Um, you know, um, so from there, let's see. 1526. Um, Sorry, I got an email that just plopped into my head, and my brain went there. Check my private one. Okay, no one else is up yet because they have lives. All right. Well, there you go. That's it. And then I just have this is my sort of instinct is have and this would be a private fund. Actually, in hindsight, these would be private. I'm going to see if I can sort of combine these in an interesting way where I don't pass a Boolean argument, because I could easily pass a Boolean argument for like is part one or is part two. That just adds in sort of that third comparison. But my instinct is I'm actually going to pass in a list of functions. I think that might be the best way to do it. And then I can combine these into a single function that just takes in a list of functions. We'll see. All right. Let me make sure I didn't break it before. All right. That's it.